Okay, so for question number 33, the first part, where it's given that A matrix is given and B's inverse is given, we have to find AB the whole inverse. And we know that AB the whole inverse is equal to B inverse into A inverse. So AB the whole inverse is equal to B inverse into A inverse. And for this, we are given with B inverse and we have to find A inverse. So let's try to find A inverse. We know that A inverse is equal to adjoint of A divided by determinant of A. So let's write down our square matrix. So it's 1, 2, negative 2, negative 1, 3, 0, 0, negative 2, 1. Okay, now let's find our determinant of this, and we are going to evaluate it along this column. So it's 1 into determinant of 3, 0, minus 2, 1. It's negative or negative 1. And if we erase a column in the row, so this is 3, negative 2, negative 3, 1. And the last one is 0, so we will just leave it. So this is 1 into 3 minus 0 plus 1 into 2 minus 4. Okay, so this is 3 and negative 2, which is equal to 1, which is not equal to 0. So this is a singular matrix, and that means A inverse is possible. So let's find out A inverse, and for that we have to find a joint of A. So for a joint of A, we will have to find out the the cofactors. So for A11, it's A11. So A11 is this is negative 1 square, and determinant of 30 30 minus 2 1, which gives minus 1 square is 1. So this is 3. So A11 is 3 and A12 is negative 1 the whole cube, and A12. So A12 is minus 1 0 0 minus 1. So this is determinant of minus 1 for A12. For this, it's minus 1 0 0 1, minus 1 0 and 0 1, which gives us this is negative and negative 1, which is 1. And for A13, which is negative 1 raised power 4, A13, the cofactor of the element negative 2. So this is minus 1 3 0 2, minus 1 3 and 0 and negative 2, which gives us minus 1 raised power 4 is 1. So this is 2. Okay, so we have A11, A12, and A13. Similarly, A21 is equal to minus 1 raised power 3, and A21 is for this. So this is 2 minus 2, 2 minus 2, and minus 2, 1, which gives us this is negative, and this is 2 minus 4, which is 2. Okay, now A22, the cofactor of the element in second row and second column. So second row and second column, this is remove the or hide the row and the column for this, which will give us 1 minus 2 0 1. So this is 1 minus 2 0 1, and here it's minus 1 raised power 4. So this is positive and this is 1. So this is equal to 1. And now A23. So A23 is minus 1 raised power 5. And if we hide the row, so A23, so A23 is 1 2 0 minus 2. So this is 1 2 and 0 minus 2, which gives us negative into minus 2, which is plus 2. Okay, so last one is a 3 1, which is minus 1 raised power 4, and 3 1 means, so this is, okay, for this it's 2 minus 2 3 0, so 2 minus 2 and 3 and 0, so this is 1 and this is 0 6, so this is 6. Okay, and it's a 3 2, so a 3 2 is minus 1 raised power 5, and the determinant for the element in third row and second column, third row and second column, 1 minus 2 minus 1 0, 1 minus 2 1 minus 2, and so 1 minus 2 and 0 1, 1 minus 2 and 0 1, 0 1, which gives us negative, and this is 1, which is equal to negative 1. Let me just check it once again. It's third row and second. So remove the second column and the third row, 1 minus 2 minus 1 0. 1 minus 2. So this is 1 minus 2 and minus 1 0. 1 minus 2, and this is minus 1 0, which will give us 0 and negative 2, which is 2. Okay, and the last one, a 3 3, which is negative 1 raised power 6 and 1 3 3. So remove. So this is 1 2 minus 1. 1 2 1 2 minus 1 3, which gives us plus. So it's 3 plus 2, which is equal to 5. So let's write down our cofactor matrix. So cofactor matrix is 3 1 2 2 1 2 6 2 and 5. This is our cofactor matrix, and adjoint of A is the transpose of the cofactor matrix. So this is now 3 2 6 1 1 2 and 2 2 5. So this is adjoint of A, and we have to find A inverse, which is adjoint of A divided by determinant of A. Determinant of A is 1. So our A inverse is simply 3 to 6. 3 to 6. This is 1 divided by 1. So this is 3, this is determinant of A is 1. So 3 to 6, 1 1 2 2 2 5. And this is our A inverse, and let's find out now. We have to find out B inverse into A inverse. So B inverse is given, it's 3 minus 1 1, and it's minus 15 6 negative 5. This is 5 minus 2 and 2. So this is B inverse, and A inverse is 3 2 6 1 1 2 and 2 2 5. Okay, let's now multiply them. So multiply them will give us, it's 3 into 3. So this is 3 into 3 plus minus 1 into 1 plus 1 into 2. This is the first element. So it's again 3 into 2. So I'm using the first row with all the columns. So 3 into 2 plus minus 1 into 1 plus 1 into 2. And the next one is 3 into 6 plus minus 1 into 2 plus 1 into 5. Similarly, for this is minus 15 into 3 plus 6 into 1 plus minus 5 into 2. So this is minus 15 into 2 plus 6 into 1 plus minus 5 into 2. Once again, it's minus 15 in 6 plus 6 into 2 plus minus 5 into 5. But the last one is 5, so this is 5 into 3 plus minus 2 into 1 plus 2 into. Okay, this is 5 into 2 plus minus 2 into 1 plus 2 into 5 into 6 plus minus 2 into 2 plus 2 into 5. And this should give us the answer. So this is now equal to 3 into 3 is 9 minus 1 plus 2, 6 minus 1 plus 2, it's 18 minus 2 plus 5. This is minus 45 plus 6, minus 45 plus 6, minus 10, minus 30 plus 6, minus 10, and minus 15 into 6 is minus 90 plus 12 minus 25. This is 15 minus 2 plus 4, 10 minus 2 plus 4, 30 minus 4 plus 10. Again, this should give us, I'm going to write the final result here. So 9 minus 1 is 8 plus 2 is 10. 6 minus 1 is 5 plus 2 is 7. 18 minus 2 is 16 plus 5 is 21. Minus 45 plus 6 minus 45 minus 10 is minus 55, and minus 55 plus 6 is minus 49. This is minus 30 minus 10 minus 40 plus 6 is minus 34. Minus 90 minus 25 is minus 115, and minus 12. This gives me negative 103. 15 minus 2 is 13 plus 4 is 17. 10 minus 2 is 8 plus 4 is 12. 30 minus 4 is 26 plus 10 is 36. So this is B inverse into A inverse. And this is our result. The final one. Okay, and let's move on to its next part. So our next part for the question number 33 is B, which we have to solve the following system of equations by using the matrix method. So let me just erase all of this. Okay, now let's move on to the second part of this question. We have to follow the following systems of equations by matrix method. And okay, our equations are, this is x plus 2y plus 3z is equal to 6. 2x minus y plus z is equal to 2. And 3x plus 2y minus 2z is equal to 3. Okay, let's write it in the matrix format. So first matrix A. So we are going to solve it as ax is equal to b and x has to be a inverse of b. So x will give us the variables x, y, and z. So our matrix A is, it's 1, 2, 3, 2, minus 1, 1, 3, 2, minus 2. And this is our matrix A. Okay. And now x. X has the variables X, Y, and Z, and B has the variables, the constants. So B is equal to 6, 2, and 3. Okay. Okay. For this, B for X. So this is now, uh, so we have B, but we don't have A inverse, so we have to find out A inverse, and A inverse is equal to, so A inverse is equal to adjoint of A divided by determinant of A. And let's first find out determinant of A. So determinant of A, let's evaluate it along first row. So this is 1 into minus 1, 1, 2, minus 2, and minus 2 into determinant of, so 2, 1, and 3 minus 2 plus 3 into determinant of 2 minus 1, 3, and 2. Okay, so this gives us 1 into 2 minus 2 minus 2 into minus 4 minus 3 plus 3 into 4 plus 3, which gives us, this is 0, this is minus 2 into minus 7 plus 3 into 4 plus 3 is 7. So this gives us 14 plus 21. Determinant of A, 14 plus 21, which is equal to 35, and that is not equal to 0. Okay, so we are done with the determinant of A. So let's keep it in the square bracket as determinant of A. Now we have to find the joint of A. So this is R matrix A. And for that, we are going to find out A11, the cofactor matrix A11, A12, A13, A21, A22. The, I'm going to find that one by one. So A11 is equal to minus 1 square and determinant of minus 1, 1, 2, minus 2, which gives me, this is 1, this is 2, minus 2, which is 3. So A11 is, which is equal to 0. So I'm just going to write the value here. So this is 0. And let's find out A12, which is minus 1 raised, and then 2, 1, 3 minus 2, which is equal to minus 1. This is minus 4 minus 3, and this is equal to 7. So A12 is 7. I'm just going to put the value here. So A12 is 7. Similarly, we can find out A13. So this is positive. A13 is 2 to the 4 minus 4 is A13. So this is 2 to the 4 and plus 3 is 7. So this is 7. So A13 is 7. Similarly, we can find out the cofactor for A21. So A21, so this is 2 into, this has the negative sign because it's minus 1 raised power 2 plus 1 is 3. So minus 1 cube, and we have the determinant 2, 1, which is 2, 3, 2 minus 2, which gives us minus 1 into minus 4 minus 6, which is 10. So this A12 is 10. So A12 is 10. Let's find out A22. So A22 is minus 1 raised power 4. And this has 1, 3, and 3 minus 2, which gives us, this is positive. This is 1 into minus 2 is minus 2 minus 9, which is negative 11. So this is negative 11. So this is negative 11, and similarly the cofactor a23 is minus 1 raised power 5, and it has the determinant 1, 2, 3, 2, which gives us negative 1, and this is 2 minus 6 minus 1 raised power minus 4, which is 4. So this is 4. A23 is equal to 4, and now it's A31, and we have to find A32 and A33. So A31 is, this is 2 plus 3, which is 5. So this is 5, and A32 is, we have negative out, and A23 is 1 minus 6. So this is also 5. A33 has positive out. For A33, it's positive out, and this is negative 1 minus negative 4, which is negative 5. So this is negative 5. Okay, now our matrix for cofactor matrix is 0, 7, 7, 10, minus 11, 4, 5, 5, and minus 5. This is cofactor matrix, and we have to find the adjoint of A, which is its transpose. So this is 0, 10, 5, 7, minus 11, 4, 7 minus 11, 4, 7 minus 11, 5, sorry. This is 7 minus 11, 5, and 7 minus 5. And this is our adjoint. Okay, let's find out A inverse, which is adjoint A divided by determinant of A. So this has to be divided by determinant of A, which is 35, which gives us 0. So this is has to be divided by 1 by 35. So which gives us, okay, this is A inverse. Let's keep it as it is. It's 1 by 35. So it's 1 by, so this is equal to 1 by 35, and it's 0, 10, 5, 7 minus 11. This is a joint. 7 minus 11, 5, 7, 4 minus 5. Okay, this is our adjoint A, and but we have to find the x. So x is equal to A inverse into A. So x is equal to A inverse, which is 1 by 35, and 0, 10. Okay, let me write it here. So this is x is equal to A inverse A, and we have find out A inverse A, which is 1 by 35 into A inverse, which is 0, 10, 5, 7 minus 11, 5, and 7, 4, and negative 5. And it has to be multiplied by b value of b is x, y, and okay, value of b is not x, y, and z, it's 6 to 3. So this is has to be multiplied with 6, 2, and 3. Okay, which gives us 1 by 35. Now 0 into 6 is 0. 10 into 2 is 20, plus 5 into 3 is 15. Next row, 7 6 are 42, minus 22 plus 15. 7 6 are 42 plus 24 minus 15. And this is now equal to 1 upon 35. This is our x, and x is x, y, and z. Since x, y, and z is equal to 20 plus 15 is 35. 42 minus 22 is 20 plus 15 is 35. 42 plus 24 is 66 minus 15 is 66 minus 15. This is not correct. So 7 into 6 is 42. 4 twos are is 8. This is 8 and minus 15. 42 plus 8 is 50 minus 15 is 35 and divide by 35 gives 111. So x y z is equal to 111. So this gives x is equal to 1, y is equal to 1, and z is equal to 1. Okay, so this solves our question number 33, both the parts. Let's move on to question number 34.